Hey everyone, and welcome back to this class, Deep Reinforcement Learning, Deep Learning in Python Part 7. In this lecture, we are going to summarize everything we learned in this section. A majority of this section was just code because we already learned all the theory we needed in the policy gradient section. The only minor difference in theory is that we use the n-step return instead of the TD return. To recap, we learned how we could have a bunch of workers learning in parallel by using multi-threading. In terms of theory, this allows us to add stability to the training algorithm because we're essentially taking the average result from a bunch of different random episodes. You hear that word a lot in reinforcement learning. The concept of stability is very central. This is mostly because stability is what is lacking. That's why we can't simply plug in a neural network into a Q-learning function approximator and expect it to work. That's why we can't plug in a neural network into the vanilla policy gradient algorithm either. And that's really the major theme of this course. Since merely plugging in neural networks into existing algorithms causes instability, then what can we do to make things more stable? With deep Q-learning, that involved creating an experience replay buffer and having a target network that didn't change too often. With A3C, that involves having multiple workers playing different episodes in parallel. At the same time, one big hurdle in reinforcement learning is hyperparameter search. So even if your algorithm and your code is sound, if you choose the wrong hyperparameters, your agent simply won't perform well. In other words, lots of resources, both in terms of compute and your own time and effort, are needed in order to really determine whether or not an algorithm works.